So in this video, we're going to be talking about how to find the derivative of a function at a particular point. And in this example, we're finding the derivative at x equals -3 of the function f of x equals negative x squared minus 4x minus 1. So the derivative is the slope of the tangent line to a function. And as we've already talked about, if we wanted to find the equation of a secant line, we would take 2 points and we would find the rise over run. Now, to find the slope of the tangent line, we can tell that by taking the limit of the slopes of secant lines, we can approximate the slope of a tangent line. So we're going to be taking the limit as x is getting closer and closer to a, and using this definition to find the slope of the tangent line at the particular point x equals -3. So for this problem, I'm going to be taking the limit as x approaches -3 of f of x minus f of -3, and then all over x minus -3. Now, the entire time I'm taking a limit, I'm asking myself, how can I find this? My first strategy would be direct substitution. But first, let's evaluate what this limit looks like. So I have the limit as x approaches -3 of my function, which is negative x squared minus 4x minus 1, and then subtract f of -3 means I'm plugging -3 into my function and evaluating it that way. So I have minus 4 times -3 minus 1. And this entire quantity is over x plus 3. So again, notice that if I plug -3 straight into this limit, I would get something that's undefined. So that means I have to either simplify this or create an equivalent expression until I can use direct substitution to plug this in. So I have the limit as x approaches -3 of negative x squared minus 4x minus 1, and then subtract. -3 squared is +9, but then with this negative it becomes -9, and then -4 times -3 is +12 minus 1. This whole thing is over x plus 3. So if I was going to combine these again and combine like terms, I have the limit as x approaches -3 of negative x squared minus 4x. This is minus 1, and then -9 plus 12 is 3, minus 1 is 2. So I have minus 1 minus 2 all over x plus 3. So again, can't use direct substitution yet, but I want to create an equivalent expression that will allow me to use direct substitution. So at this point, the second strategy I might use is to try to factor my numerator so I can cancel out terms in the denominator and create an expression that would not be undefined as I'm taking the limit of x approaching -3. So here I have negative x squared minus 4x minus 3 over x plus 3. I can try to factor this directly, or I can note that I can factor out the negative, and then I'll have x squared plus 4x plus 3, and these are equivalent. So now that I'm trying to factor my numerator, I have the limit as x approaches -3 of negative x squared plus 4x plus 3. This can factor to, let's see, x plus 3 times x plus 1. And at this point, I can see that I can cancel out these terms. So now I should finally be able to use direct substitution to calculate this limit. And I have negative x plus 1. So altogether, this would become negative 3 plus 1, -3 plus 1, which is -2, or 2. So using this definition in conclusion, we're able to say that the derivative of the function f of x equals negative x squared minus 4x minus 1 at x equals negative 3 is 2.